Assalamu alaikum. How are everybody? Today, Chemistry Chapter 6, Section 3, Ionic Bonding and Ionic Compounds. The objectives of our lesson is to explain how ionic bond is formed, compare a chemical formula for molecular compounds and ionic compounds, discuss the arrangement of ions in a crystal, and last, compare the distinctive properties of ionic and molecular compounds, and finally write the Lattice structure for polyatomic ions. First, what's ionic bond? How the ionic bond is formed? We discussed before the formation of covalent bond, and we mentioned that in covalent bond, the two atoms share with each other. In the covalent bond, let's discuss an example to show the covalent bond. For example, sodium Na has one valence electron, only one valence electron. And chlorine has 7 valence electrons. What happens? Sodium loses one electron to chlorine. So sodium, the outermost energy level now, has 8 electrons, which is the second, the third. The electron here exists in the third energy level. So it loses this electron to chlorine. Chlorine now is completed with 8 electrons. So sodium becomes positive and the chlorine becomes negative. And the attraction force exists between them to form sodium chloride. So this is the formation of ionic bonds. One atom loses and one atom gains. The atom that loses electron is called cation or positive ion, and the atom that gains an electron is called anion or negative ion. Okay, clear? So this type of bond between two atoms form ionic compounds. Ionic compounds consist of positive ions, cations, and negative ions, anions, held together by ionic bonds. So the ionic bond form ionic compounds. For example, here NaCl. Example NaCl, as you can see, here consists of sodium ions, positive sodium ions, and chlorine negative ions by the ratio 1 to 1. If you count the number of sodium ions and the number of chloride ions or chloride, they will be equal. So the ratio is 1 to 1. And the positive charge is balanced by the negative charge. This structure is called crystal lattice or lattice structure. This arrangement is called lattice structure. Most ionic compounds exist in crystalline solids. Like as we see, the crystal of any ionic compound is a 3D network of positive and negative ions, mutually attracted to each other. Positive and negative ions, 3D network, they are attracted to each other. In ionic crystals, ions minimize their potential energy because they come closer to each other by combining in an order arrangement known as crystal lattice. So crystal lattice is ordered arrangement of ions, like as you can see here for this sodium chloride, sodium chlorine atom, chlorine ion, sodium, chlorine, and so on. This arrangement is called crystal lattice. Like here in cesium chloride, as you can see also cesium chloride, this arrangement chlorine atoms or chloride ions and cesium ion. This arrangement is called crystal lattice. So attractive force exists between opposite charged ions within the lattice between positive and negative ions, there is attraction force. And also repulsive exists between like charged ions, like this negative and this negative, there is a repulsion force between them. This negative and this negative, repulsion between them. So we have attraction force and repulsion force. And combining attractive and repulsive force determines the distance between ions. The distance between ions depends on the attractive and the repulsive force and the pattern of the ions arranged in the crystal. The pattern of ions arranged in the crystal, the shape itself depends on the attraction and repulsion force. You should notice that ionic compounds are not composed of independent neutral units that can be isolated. They are not formed of molecules. They don't have molecules, not formed of molecules, and molecules here do not exist. The chemical formula of ionic compound does not represent molecules, but the simplest ratio of ions, because here not separated units are formed. But as you can see in the figure, in the first figure, you can see here the atoms are arranged in a specific pattern, okay, and they are not separate from each other. They are linked to each other. So we count the number of atoms. Like here, the ratio is 1 to 1, because the number of green atoms here, green colored atoms, a number of blue colored atoms are the same. So the ratio is 1 to 1. Here, in the second figure, the ratio between the orange colored atoms and the blue colored atoms is 1 to 2. So the ratio here 1 to 2 or 2 to 1. So here it's called the simplest ratio. So it's called formula unit. Formula unit is the simplest ratio of atoms of an ionic compound. Means what? For example, sodium chloride. This represents sodium chloride. Sodium chloride NaCl, one atom of sodium, one atom of chlorine. Why? Because the ratio is 30 to 30, 60 to 60, 100 to 100, so the ratio equals 1. Here, like for example, magnesium chloride, MgCl2, means what? 1 magnesium and 2 chlorine. The ratio is 1 to 2, 10 to 20, 20 to 40, 30 to 60, and so on. So they are not separated, so we use formula unit, the simplest ratio. So we use formula unit for ionic compounds because they don't have molecules. Ionic compounds versus covalent compounds. Here, atom A and atom B, they combine together to form ionic compounds. Electrons transferred from one atom to the other atom. So positive ions are formed and negative ions are formed. In the covalent, they just share. Atom C and atom D, electron pair share between atom C and atom D. So they share. No positive, no negative. Let's compare now between ionic and molecular compounds. Ionic compounds and molecular compounds. In the ionic compounds, strong electrostatic attraction holds the atom together. Strong electrostatic attraction. The attraction between positive and negative ions is stronger, while here the attraction is weak. So the first point, attraction force between molecules are much weaker. This is the first point. Ionic compounds have high melting points, while molecular compounds have low melting points. Ionic compounds are hard, they are solid and hard, but brittle, can be broken. While molecular compounds, they can be liquids, gases or solids, but soft solids can be melted easily. Solid ionic compounds are not conductors. No electrical conductivity in the solid form because ions cannot move. In the solid form, the ions cannot move. So they are insulators, like sodium chloride. Sodium chloride in its solid form is an insulator. But if you dissolve it in water, it will conduct electricity because in this case the ions can move. If it's a molten sodium chloride, also conduct electricity because ions now can move. While in the solid form, no electrical conductivity in the solid form. While here they are also insulators. Here is a table for the melting and the boiling points of some compounds. The first three compounds are ionic and the rest are covalent. Notice that here melting point is high. Why here the melting point is low? This is liquid at normal atmospheric pressure. Here melting point equal 27. Start to melt at 27. Here some gases. So the melting points of ionic compounds are higher. Polyatomic ion. Poly means many. Atomic means consists of many ions. So these ions, negative or positive ions, consist of many atoms. For example, so a charged group of covalently bonded atoms is called polyatomic ions. Charged group, the whole charge, the all over charge has charge here. The total charged group of covalently bonded atoms. These atoms are bonded covalently, but as a whole they have a charge. For example, ammonium ion, 1 atom of nitrogen and 4 atoms of hydrogen. It's called ammonium ion. Its ionate here can be represented as ionate. It's called ion. Nitrate ion, NO3, here NH4. Sulfate, SO4, has negative charge, -2. Here nitrate, -1, and ammonium, +1. So like other ions, polyatomic ions have a charge that results from either a shortage or excess of electrons. Here, electrons lost. Shortage of electrons. Here, electron is gained. Here, 2 electrons are gained. So here, -2, here, -1. Discuss an example, which is ammonia, NH4. It's sometimes written as NH4 square brackets +1, to show that the group of atoms as a whole has a charge of +1. So the square bracket here means that the group of atoms has a whole charge, the total charge of the 4 atoms here. Why it's positive charge? The charge of ammonium ion is determined as follows: 7 protons in N atom and 4 protons in 4 atoms. We have here, so nitrogen has 7 protons, and each hydrogen has 1 proton, so we have here 4. So 4 plus 7 equals 11 protons, 11 positive protons. While the electron, what about the electrons? When N and H atoms combine to form ammonium ion, one of their electrons lost. The number of electrons here should be 11, but 1 is lost. So the dV will be -10. So the number of electrons here 10, so the charge is -10. The total charge is therefore +11 plus -10 equals +1. And so on. If you apply this to the other polyatomic ions, here nitrate means the number of electrons exceeds the number of protons by 1. Here the number of electrons exceeds the number of protons by 2, so the charge here is -2. This is the last point in our lesson. Thanks a lot. Until we meet again in our next lesson.